So what we are going to do is called the separate file compilation, or called the multi-file management using tool named Make. So we are going to learn the use of a utility, Linux utility called Make. Make is a project management tool. If you have a multi-file project, how to manage that. So before that, what we want to understand is how the compilation and the a.out is generated. So here we created the coin.h and the coin.cpp. I told you how to separate it. In .h, you never ever give any body part of the function, just the prototype only, very strictly. Even if the body of the function is very simple, just initializing or return only. But no matter how small the body is, never ever give any body part. And then do the body part in .cpp. The reason why we do this one is if we separate this way, .h has no execution code. .h is just information only about the class, just information, specification only. .h never ever produces any executable code at all. But only .cpp contains executable code. So when you compile in Linux, you use the G++ and the file name, and then a.out is produced, and a.out is called executable code. But when you do this one, actually two steps are involved. That is called the first step is called the compile step. Second step is called the link step. If you use IDE, NetBeans, Visual Studio, Xcode, or whatever, you have some button to run the program, and then the button is usually called build, right? Build, something like that. Build. The build is actually a combination of those two. So compile means translate the source code into executable one. And the link means for each converted one, put them together with the library. So in a very simple program in main.cpp, if you did a c.out, hello world, your code simply says c.out, but you have never written code for c.out yourself, right? So you use from the library. So your code is compiled. And then finally, your compiled code is linked together with a library, IOStream library. That produces the a.out. So compile means compile only for each file. For each file, which is a CPP only, since .h is information only. For each CPP file, just translate it. And then when translation is all done, now put together with the library to produce a.out. That's the procedure. So if we have separated that way, so coin.cpp.h is never translated for executable code, which will be translated into coin.o. So this O is a object code. That means it's not an executable code yet because it's not linked with the library, but it is translated from C++ to object code, machine language code for CPU. Only this portion, not including any library. And similarly, piggybank.cpp could be, so simply this file alone could be translated for machine code. If you do that, .o will be created. And the main.cpp, including main function, could be translated by itself, standalone, produces object. So this is called the compile-only steps for each physical file. And then link step is put those three files, .o files together with any library you use. IOStream library, string library, or method library, depending on what kind of code you go. So with the library together produces a.out, which is executable code. Why we do this way is if you change coin.cpp only, some of the implementation I want to update, coin.cpp only, then chances are you don't have to retranslate the other files. But if dependence is there, we need to update it though. So why do we this way is save time in compilation. If you change one of the file, then let's limit the retranslation for that and then dependent ones only. Not everything, whole things again. Okay. If you change in main.cpp, chances are you don't have to retranslate coin or piggy bank. Something like that. So in that way, we can save time in building the executable code. Then how do we do that is as follows. So let me show you how to do that manually. So G++, you have a -C option. That's called the compile only option. Then if I do coin.cpp, then only coin.cpp file is translated independently. Then now I get coin.o. So coin.o is a translation of coin.cpp, not using anything else, not even library. So coin.cpp has no syntax error, so it's compiled. So similarly, piggybank.cpp, no error. So I have a piggybank.o produced here. So coin, piggybank, it's independently translated. And let's do similarly for main.cpp, no error. So we have a main.o. So each file is independently translated. And now we put together like this. All translated one, dado, just to use a G++. Then those three are put together and whatever library being used. So that's called the link step. Finally, we have a.out produced here. These steps are done automatically if you simply do G++ star.c. All of these things that's taken care. But here, suppose I change main.cpp only. So here I add the insert. Suppose I insert C1 again. One more coin is added. Then I have a coin, piggybank, main.cpp. I don't have to retranslate the coin, right? Coin is just used there, and I don't have to retranslate the piggy bank. The only thing I need to retranslate is main.cpp. So main.cpp alone is retranslated, and then I just put them together again. Main.cpp, main.o is updated. Now the other two remains unchanged. Put together. If I run it, now 3 coins are added. Something like that. But if I do G++ like this, anyway, I retranslate the coin again, piggy bank again, and the main again. So it's a waste of time. Of course, by separating it, you save only a fraction of a microsecond though. But if you do huge project, if one file takes 1 minute to compile, it's a very complex code. And you have a ton, dozens of such files. Then retranslating the whole files again, dozens of files again, may take more than 20 minutes. But if you change one file, retranslate that corresponding file only, it will take only 1 minute only. So you save more than 10 minutes and so on. So that's a benefit of separating, compiling separately. But if you do manually, it is a very time-consuming process. So Linux provides you with the make utility. This is only for Linux. In Windows or Mac or any IDE, this is done automatically inside. It's hidden. as you press the button, run button, or a start button, all of these are done internally automatically. It's inside hidden. It's not explicitly visible, but in Linux, you can do control all by yourself. So here, in this one, let me clean up .o, a.out. Suppose I have a source code only, then how do I set up for separate file compilation? This will be required for each assignment you do here. So take a look at this one. First, I need to create a simple text file using editor. So now I'm using VI editor. You can use a Nano or whatever. The name of the file is capital M Makefile. Okay? Capital M Makefile is name of the file. No suffix required, just a Makefile. So use this name only. Here, what I do is, how do you produce a.out? That's the first line. So blank line is ignored. So what you do here is, how do I produce a.out? A.out colon. Here, what you say is to produce a.out, what do you need immediately? Remember how I did step by step, compile only and link together, right? So to produce a.out, I need main.o, coin.o, coin.o, and then piggybank.o. Those are three compiled code are needed. So to produce a.out, I need those three. Specify first line. And second line, very important thing is, many of you may forget is, the second line, the very first character should be tab. If you put multiple blanks, it will not work. It's a very weird requirement, okay? You should press the physical tab key, okay? Pressing the tab key and then write Linux command for that. How do you produce a.out? The Linux command is a g++, main.o, coin.o, piggybank.o. That's how to produce a.out, right? So in a Makefile, you put information 2 lines at a time. So the very first line is how to produce a.out. A.out colon and what you need. And the second line, Linux command for producing a.out. And then blank is also readability. You don't have to put blank lines, but I put blank anyway. And then what I do next is, to produce a.out, I needed the main.o, coin.o, piggybank.o. So for each of those input for a.out, specify how to produce them. So let's begin with the coin. Coin.o is one of 3 things for a.out, right? So I need to produce coin.o. To produce coin.o, what do you need? Coin.cpp, also coin.h is needed. Why is it so? If I take a look at coin.cpp, coin.h is included, right? So coin.cpp depends on coin.h. So here, to produce coin.o, I need the coin.cpp. Coin.cpp should be translated, but coin.h is also needed because coin.cpp depends on coin.h. Tab, don't forget. Now, how do you produce coin.o out of coin.cpp? G++ minus C, coin.cpp, right? Next line. Coin.o is taken care. Let's take care of a piggybank. So I need to produce piggybank.o. What do you need? Piggybank.cpp. And inside the piggybank.cpp, I include piggybank.h. And inside the piggybank.h, I include another one. Coin.h include. So those are called the dependency. Okay? So you need to list what you need, the CPP, and then what are dependents of that. That should be specified. What? Tab minus C, CPP. So two of those things are taken care for a.out. So the last thing is main.o. I need the main.cpp. Also dependencies are piggybank.h is included. Also coin.h is included in main program. How do you produce main.o? Now all of the dependencies are taken care. All three for a.out is taken care. For coin.o, those two are simply source code. It's created, right? So piggybank.o, .cpp.h, all of those are created by the editor and so on. So there is no further dependency there. So this is what you need to specify in Makefile. Then how do I use that is a utility named make. If you simply type make, those compilation link is done automatically. So main is compiled, coin is compiled, piggybank is compiled, put together to produce a.out. So all of those one. So if I change main.cpp, so I put one more coin, then I need to recompile main.cpp only, right? So if I simply type make, only that is recompiled and then link together to produce a.out. But if I change coin.h to put something else, the coin.h is changed. Then dependency says that coin.h changed, coin recompiled, coin.h, piggybank need to be recompiled, main needs to be recompiled. So if I do make, so everything is recompiled. So dependency information from Makefile is utilized for make utility to determine which should be retranslated. So this one in Visual Studio, internally it uses this one. So in Visual Studio, if you edit to one of the file, it does not simply recompile everything blindly, but using internal Makefile system, only corresponding one and the dependent ones are recompiled automatically. But Linux, you should take care of it yourself. Question?